Okay, welcome back everyone. I'm just recording a short video here. In my introduction, I thought it best if I split it up into two parts. The second part here, what I want you to think about is the language that we use, and I call this like the small details that we need to play the game. We need to understand the language and the words that we use. So we need to know the difference between algebraic terms and constant terms. The best way to think about this is if you've got numbers and letters all multiplied together, you've got an algebraic term, for example. I just think about the constant terms as the numbers hanging around at the end, because if we think about BODMAS, the last things that we do are either addition or subtraction. So in the process of substitution and evaluation, for example, if we had plus 12, the very last thing that we're going to do is add 12. And the other part of this video is all about generalizing. I don't think we stop enough and talk about it. And for example, in the textbook that you're working in, I've only found one really good question that actually allows you to generalize, okay? And get out of that little specific box that has some sort of constructed algebraic problem in inverted commas. And one of the big things I want you to do, even though you might not have the skill set to do this at the moment, is try to picture mapping out what these algebraic expressions are getting you to think about. And you can use a table, but I really like visual ways of doing things. So in this video here, I'm going to offer you a way to map out the 2 times tables, for example, and be really general about what that actually means. So let's get behind the light board and show you what I'm thinking about. Now I've just cleaned the board. I just want to talk more about these pronumerals, and I'm going to call this section the small details. They're things that we need to know, okay? For example, these pronumerals, these letters, they could be any letter of the alphabet. They could be uppercase, lowercase, generally lowercase through to Z. Now, we can also have a couple of letters combined together. And how we do this, we need to be really careful about this. We might have A times A, and we often don't write that like that. We've got any number times by exactly the same number, well, that's going to square the number. So being very general here, we're going to write this as A squared. And you need to be aware of what that little notation up there is telling you, that whatever the value of A is, we're multiplying it by itself. So just on this point here, we you might see this A and a dot in the middle to represent multiplication, and we might write that as A squared as well. It's really important to see that little dot, and I've made it a lot bigger than what it normally is, right? Because it means multiply as well, okay? And you might see that kind of notation. And I just want to point something out to you. When you're writing your letters, let's be really careful that we write we often use X. Let's be really careful how we write our X, because we don't want to confuse it with the time sign. Okay. And of course we can have 2 different letters multiplied together. And what we generally write here is AB. Or you might even see this. We've written it without the multiply sign. So what's happening in here is what's called implied multiplication. Okay? Got to get used to seeing those two letters joined together without any symbol between them as multiplied. Okay? In the same sort of way that you might see, instead of seeing A divided by B, we kind of set that up as a fraction, A over B. And that's really useful to set it up this way without the division sign. And that comes back to a bit of our knowledge about what this division sign actually represents. And I'm just going to use a box here, and because it's something on your calculator as well, that's a fraction button, okay? But what's it saying? We've got a numerator divided by a denominator. A is our numerator, B is our denominator. So we're quite comfortable setting it up as a fraction, or we should get used to that idea. So there's a couple more things that we need to look at, and I might write something out here, and this is an algebraic expression. And these are the small details, guys. Because it hasn't got an equal sign, there's no equal sign. We could write the same thing out again, and I might do that over here when we have an equation. We've got an equal sign. So we might call this y equals 5n plus 2. Okay, I hope that's still on the board. They're the subtle differences in the words that are being used. So an expression, what we've got in front of us here, does not have a equal sign in it. All right? So some of the other words you might see, this 5, remember this is 5 times n, we call this the coefficient. The coefficient, C-I-E-N-T, coefficient, that I'm just going to put a little dot in here to represent multiplication. This is 5 times n. Whatever the value of n is, we're going to multiply it by 5 in the process. And then this bit hanging around the end, plus 2, I just think about them as the numbers hanging around the end. This is a constant. And it's just called a constant because what we're doing when we crunch the numbers, we're constantly adding to the number that we generate. Okay, so coefficient, we've got the letter in here being the pronumeral, the letter n, and then the constant being add to, that could be subtract to. Okay, they're just numbers. It's not the term that we see here, and it might be good to write this down. The algebraic term in this expression up here is 5n. That is the combination of the coefficient, the number, multiplied by whatever combination of letters that we've got. Okay, so finally, while we're here, I think it's a really good idea. I'm going to use this little bit of space over here. It's a really good idea to remember these words. Sum of, meaning we add things together. Difference, meaning we subtract one thing from the other. Product, we multiply. And quotient, when you see this word here, we've got to remember division, okay? So they're the words that we use to link up the mathematical operation. And these, like I said up the top here, these are the small details that we need to remember when we look through the questions. And that will help us with our mathematics. I'm going to clean the board. I've got one more thing to say, and that's on what we're doing with algebra, and that is we're finding a way to generalize what we're doing, okay? I'm really keen to point out some of the big picture reasons why we're doing what we're doing. We're taking the baby steps at the moment. We're teaching you about the basics of algebra, but there's a bigger picture here. And I say it goes beyond just thinking about questions where we're trying to divide up a restaurant bill that we don't know. Or even, we've got a certain number of apples and we're going to call that A. And we've got some oranges, we're going to call them O. And we've got bananas called B and all that kind of stuff, which is the kind of examples that you see in the textbook. We want to look at the bigger picture. We want to use algebra because we can generalize, okay? I've written out the 2 times tables here, and you learn these things, and I'm just going to draw a box around these numbers, and I see this as algebra, okay? So far you might just see it as, oh dear me, I've got to learn my 2 times tables or whatever times tables. I see this, if we just called this X, all this work here is the 2 times tables or 2x. I'm going to write an equation. I'm going to write y equals 2x. Okay, that's what we're dealing with in the 2 times tables. Now I'm going to call it an algebra machine. Okay, I'm just going to draw a box. And we've got an input here where we can put a number in and crunch the numbers or pull the handle down, and we're going to spit out a number. Let's play around with this. If we put in a 0, what do we get out as our output? Well, 2 times 0 is 0. If we put in a 1, 2 times 1 is 2. Put in a 2, for example, and what do we get? Y equals 2 times 2, which is equal to 4. Okay, inside our machine, every time we push the handle, put one number in, we get one number out. We got 4, and we could just, over here, we could continue on down here, produce this pattern here. Now, the key thing here to realize is that we can put any number we like into this machine. We put one number in as our input, and we pull the handle down over here, and we get one number out as the output. So, again, we're kind of generalizing. Well, what does that look like? What's a map for this algebra machine? Where are all the numbers? And even though you don't do it just yet, I really think it's important that you begin to think graphically. Okay, so here's our output. We're going to put the numbers in along the x-axis here. We've got 0 in the middle. We've got 1. We've got 2. We've got 3. Maybe that's enough. So our output was, when we put 0 in, we got 0 out. When we put 1 in, we got 2 out. When we put 2 in, we got 4 out. When we put 3 in, we got 6 out. Okay? And we're doing this. And hopefully we realize that that's going to go on forever. Okay? If we could just keep stuffing bigger and bigger numbers in, we're going to go towards the positive side of infinity here. And just as importantly, well, what happens if we put a negative number in to this machine? What are we going to get out? The magnitude of the number is the same, but the sign is different. So I've just changed the color of my pen here, where we put in -1, we get -2 out. We put in -2 here into the machine as our input, and what do we get out? We get -4 out of that, and then -6. So not only that, we've got a general idea of what this algebra machine in here is going to produce. And this is going to tend towards the negative side of infinity. Here, if we keep going, those arrows represent, the line continues on. So I think it's really important, as on the road to learning algebra, is keep an eye on what the bigger picture is. And as we're learning things, we're actually learning to build up the capacity to do the next step, where we're generalizing, okay? And that's the hardest thing, I think, for guys to understand, is that we're not producing one, often we're not producing one answer, okay? And we're starting to shift our thinking in towards, well, with this equation here, y equals 2x, depending on the numbers that I put in, I'm going to get certain numbers out, and those numbers are going to fall on this line here that I've made up, okay? So hopefully that's a helpful introduction for you to algebra. Keep persisting with it, keep building your skills.